Graphing in applied behavior analysis. It gives us a means for organizing our data during the data collection process. So, when we are collecting data, we are typically going to be recording that data on a data sheet, which means that we are going to have a lot of data sheets. So, organizing all that data and putting it into a graph, that's an overall visual representation of those data, gives us just a really good way to organize everything so we can see what's going on. Second, since we do have the ongoing picture, it allows us to have a possible to make a formative evaluation as we provide the treatment or the intervention. So, we can always look at the graph and see if our behavior is increasing or decreasing like it is supposed to be. And if it is not, then allow us to talk about things and change something. And lastly, it serves as a really good vehicle for communication between anybody that's involved with the intervention. So, the teacher, the parent, student, etc., if we have this really clear graph that has organized the data, that provides a visual representation of what's going on. So, we can really clearly see what's going on with the learner and the specific behavior that we are taking the data on, and it just allows us to communicate better about what's going on between different people that are involved in the intervention. So, all these are the reasons why we grab all our data in ABA and try to present it on the graph. So, when we talk about graph, we have x axis and y axis. So line graphs are mostly used for these purposes. There are some specific components that we must understand. So what is x-axis? It is at the bottom. The horizontal line is called x-axis, and typically x-axis shows how frequently the data was collected. So it's usually a measure of time. So sessions, days, dates, things like these are represented on the x-axis. And now, what is y-axis? Y-axis are the vertical line of the left side of the graph. And here we label it. Y-axis actually identifies the target behavior and the kind of the data that's being reported. So, for a specific example, these are data on two-digit multiplication problem, and they are problems per minute. So that tells us that these researchers are measuring the rate. You also need to have the data point, and which are these little data points. Moving forward, we must understand that how this target behavior per session per day is collected. You need to have the data path, which are the lines that connect your data points. And your data path allow us to see the trend of the data, what direction the data are going in. If you look in this baseline phase, it is pretty clear, but if you look in the intervention phase, then you can really see that these are increasing in the trend of the data. You need to have a phase line. So these are the lines that separate you of two different phases. So typically in a line graph, you're going to have a baseline phase, and this is just when you measure the behavior under natural conditions. So how often is behavior occurring naturally. You put a phase line into to demonstrate that you're implementing a treatment, an intervention, and then you see that what happens to behavior after you implement a treatment or during the treatment, and that would be your treatment condition. Then you need to have phase levels. So your phase labels are up here. So somebody is looking at the grass can tell which is your baseline phase and which is your intervention phase. And then last, you need to make sure that you identify which student this data is for. And typically, we do that right over here on the right side. You put their name in the box and it goes right above the x-axis. So these are all the major components of your graph, specifically the line graph. And as you guys can see this, it's really clear. There is no color on it. Graph is typically black and white. There are no grid lines. You want to see and understand it, you can do it very well. So you have understood the ordinates, the phase labels, the phase lines, the data points, the data path, and how do we identify the student identity. Summary of data conversion process. As we see, there are multiple recordings we do under ABA, and those are our measurement procedures. Every measurement leads to data, and that resulting data need to be presented in the form of a graph. So under this table, I'm going to explain to you that what kind of a measurement procedure will lead to what kind of a graphical presentation. So let's first understand the procedures. Event recording. In this, we actually record each instance of a behavior as it occurs. Behavior can occur at any time. So when we talk about even it is a continuous measurement, that is why frequency is very important. But if the base is changing, the time is changing, then we need to draw a graph of the rate. Otherwise, we can directly draw the frequency. For example, a number of biting instances in 5 seconds or 5 minutes. And then we see every 5 minutes number, how many times did the child started biting himself or others or whatever. But if the time is changing, that first we observe for 5 minutes and then we observe for 10 minutes and then we observe for 20 minutes or whatever, then in that case, number of biting divided by the time, which will give us the rate, and rate should be drawn onto the y-axis. X-axis will always remember the time. So whether it is minutes or days or hours or whatever. Moving forward, opportunity recording. Opportunity recording is a record each instance of behavior as it occurs. It needs to be an opportunity for the behavior to occur. And in this also we either draw the frequency directly or we calculate the percentage of the opportunity. So what was the percentage, and that we take it on the y-axis. Partial interval recording. Partial interval recording is a discontinuous measurement, and in this the recording of whether a behavior occurred at all the during this specific time interval. Say for example, we make the bins of 5 seconds. So if behavior occur even for 1 second, it is counted. So there are multiple bins, say there are 10 bins, there are of multiple time intervals, and then we say that only 3 bins have a tick mark because the behavior occurred during that time. So we take the percentage of the intervals in which the behavior occurred. So that means, say for example, we are observing a behavior in 10 5-second slot and only 3 are ticked. So that means 3 out of 10 multiplied by 100. So in that case, what percentage it becomes when it is 3 out of 10 means 30 percentage. So that way we calculate the percentage and then demonstrate that on to the graphical presentation. Whole interval recording. Record whether a behavior occurred the whole time during that specific time intervals for a defined observation period. So say for example, if we have 5 seconds, 10 intervals, so if the time appears, if the certain behavior appears for the full block, so total 5 seconds, if the behavior is appearing, then only we put a tick mark. And exactly like the partial interval recording, the number of tick marks which are there, but the only difference is in the recording of the data. And then we calculate the percentage of intervals in which the behavior occurred. So say for example, if it is 4 bins are ticked in, that right from the beginning to the end of the 5th second the behavior was occurring, in that case we say 4 divided by 10 multiplied by 100 and 40 percentage. So the percentage is drawn on the y-axis. Next, time sampling recording. What is time sampling recording? Where we record whether the behavior occurred at the end of the specific time interval for the defined observation periods. So if we are making 10 bins of 5 seconds, we see every 5th second, 10th second, 15th second, 20th second, was the behavior there? If yes, we put a tick mark. If no, we put a cross. And after that, exactly like partial interval and whole interval, we find how many bins are ticked and calculate the percentage of the interval in which the behavior occurred and draw that on the y-axis. Moving forward is the duration recording. In this, we record the amount of the time from onset to the offset of each behavior as it occurs. So because this is duration, we are recording the time. So what would we draw on the y-axis? Of course, we can draw the duration, the total duration, we can draw the percentage of the duration, or we can even draw the mean duration. So it can be either of these on your y-axis. X-axis, as we always said, are the number of sessions, day, date, time, etc. Latency recording. So what do we do in latency? Actually, that is a record of the amount of time that passes between the antecedent and the onset of a behavior. So when we say antecedent means SD, the discriminative stimulus. So once the instruction is given and the time taken to start the behavior is called the latency recording. What do we draw in the graph? We draw the total latency or the mean latency. Moving forward is intensity recording. Intensity recording is what? It records the dimension of intensity, the force, the volume for each instance of behavior. Now, what do we draw? So we can draw various things. We can draw mean decibels, we can draw mean rating per event depending upon what is the target behavior. Moving forward is a permanent product recording. So this is a document the effects of a behavior on the environment. So various things which we can record could be the wound size, the number of holes in the wall, or the number of math problems completed. So once we know that, we are able to draw a graph accordingly. And this is the description about all the multiple types of recordings which we do it. And now let's understand each one of it clearly in terms of how do we do it. Event recording. Student name is Stephen. Behavior is packet assembly. Observation period is vocational training at Red Cross. If we see the day, 16th of April, 18th of April, 20th of April, 24th of April, etc. Monday, Wednesday, Friday, Tuesday, Thursday, days are written. Now, number completed and amount of time. So number completed is 45, amount of time is 30. So 45 divided by 30, which is 1.5, and that is the rate per minute. So per minute, how many? Similarly, 40 divided by 25 and 1.6 is the rate per minute. Now, if you come to the graph section, days are on the x-axis and the number of packets assembled per minute is on the y-axis, and the line graph clearly indicates that what's been the trend, so how it is increasing. Moving forward to interval and time sampling recording. So look at this chart, which is a data collection sheet. Student name is Leanne. Behavior is self-talk versus other directed during the play. So S indicates the self-talk and O indicates the other directed talk. And on Monday, it shows that there are 20 bins, and certain bins are empty, certain bins indicate the self-talk, certain bins indicates the other-oriented talk. So we are doing the interval and time sampling recording. Monday, Tuesday, Wednesday, Thursday, Friday, the data is there. And then this data is counted, and then we calculate the percent of the interval of talk. So what we are doing is, as you see the two lines, one is the self-talk and the other one is the other directed talk. Sessions are on the x-axis. So let's count on Monday how many S's are there. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 out of 20 out of 100 what? So 10 divided by 20 multiplied by 100, and that shows 50%. So self-talk on Monday is 50%. So that's the first day. And then we go on to the second day. So if we're looking at the self-talk, we have 1, 2, 3, 4. 4 divided by 20 multiplied by 100 is 20%. So it will be indicated. That is how we do the self-talk. Similarly, we also calculate the other talk. On day 1, there are 4 out of 20 other talk. So 4 divided by 20, and then we multiply it with 100, and that is what indicates 20% of the other directed talks. So time and interval sampling graph is clear to you. You understand how to present it for others in a pictorial mode to understand. So in clarity, you have learned that how to draw the graphs in multiple recording and data sessions. So now we come to a summary. What have we learned in this video? The purpose of graphing, the components of graph, the data conversion process, which is very important, and then we had couple of examples. So I wish you all a great time doing the graphs in ABA.